Okay? So go ahead and try this one. You have 2 moles of hydrogen sulfide gas yielding 2 moles of hydrogen gas and 1 mole of sulfur gas. When 0.1 mole of hydrogen sulfide was put into a 10-liter vessel and heated to 1132 degrees C, it gave an equilibrium mixture containing 0.0285 moles of hydrogen gas. What is the value of Kc at this temperature? Yeah.
So is the temperature just like irrelevant?
You don't need the temperature in these problems.
Okay. They just
Well, what you have to remember is that because the equilibrium constant is based on reaction kinetics, it's a collection of kinetic constants, and they are temperature dependent. Equilibrium is temperature dependent. So all these reactions are done at a specific temperature, and that's why they give it to you. Do you need it? No.
Yeah, because if they didn't state that, then it's just stating it so you know that it's constant, like a constant temperature.
Yeah, you have to be at that temperature. Otherwise, you're going to have a different value. K will always change based on the temperature. So what I've done at this point is, the first thing I needed to do was get into molarity units. I took the concentration of the hydrogen, determined the concentration of the hydrogen sulfide by taking the 0.1 mole, dividing it by 10 liters, and I got 0.01 molar. That is the initial concentration of the hydrogen sulfide. For the hydrogen gas, they told us that we have an equilibrium mixture, so this is an equilibrium concentration of 0.0285 moles of hydrogen gas. I'm going to divide that by 10 liters, and I get 0.00285. Yes, my 2's are starting to look like 7's. There, that's it, 0.00285. Now I set up my ice table. Ice, baby.
Try to stop. I'm not ready to listen.
Where's my volume? Oh.
You're plugging, aren't you?
I have it on.
Are
Damn
you
it.
serious?
Yeah, but I don't have any volume. It ruins it. volume on this stupid thing. They're killing me here, people. They're killing me. Oh, main volume. I have the volume up. The volume's all the way up.
Do you have it playing on that computer?
No, it's on this computer.
Is the volume on that one up?
This one, right here, yeah.
Yeah, is the volume on that on?
Yeah, it's cranked up. It must not be on that thing.
Try the buttons. Kind of disappointed.
Oh, I ruined it. All right, anyway. So, the question is here, do I actually have x in this problem? No, I have 2x. So right now, to figure out what x is, I'm going to take 2x, which is my hydrogen, and that has to be equal to 0.00285. So divide both sides of this by 2. I get x is equal to 0.00143 molar. And that gives me the concentration of the sulfur. If I want to calculate out the concentration of the hydrogen sulfide, so the concentration of the hydrogen sulfide is going to be equal to 0.01 minus 0.00285. So my new concentration will be 0.00715. And of course my hydrogen concentration was this. Now I can plug it into the equilibrium expression Kc. So Kc, oops, is going to be equal to the concentration of the hydrogen. What should I do with that one? I should square it. Times the concentration of the sulfur. Divide that by the concentration of the hydrogen sulfide, which also is squared. Now I'm just going to plug everything in. So the hydrogen is going to be 0.00285 squared. Multiply that by 0.00143 and divide that by 0.00715 and square that. So 0.00285 squared, multiply that by 0.00143, and then divide that by 0.00715 squared. I get 2.27 times 10 to the negative 4. And there are no units for the equilibrium constant. 2.27 times 10 to the negative 4.